In this video, we are going to look at generics, or also known parameterized classes. The objective of this lecture and video is to understand the objective of generic programming, to be able to implement generic classes and methods, to know the limitation of generic programming in Java, and finally to understand the relationship between generic type and inheritance. But what is the problem we want to address? We want to implement an abstract data structure, such as a stack, for many different types, such as an integer, double, string, or other self-defined object. We want to implement algorithms for different types, such as merge sort, for integer, double, string, or any comparable user-defined object. With our current knowledge, we must either create a class additive and method for algorithm for each type. For example, we need to have one for an array stack integer, one for an array stack of string, and so on and so on. We need to create a class for each type of object, and then cast the element into the desired type. The latter leads to unsafe type checking. That is, the compiler cannot enforce type checking on this class or method. We are going to be able to see that with the class arrayStackObject. So let's see some example. First, we want to create an interface to represent a stack. So we want to create an interface iStack. But we want to be able to do that with integer, and string, and object. So we need to create three interfaces. iStack integer, to be able to deal with integer. iStack string, to be able to handle a stack of string. And iStack object, to be able to handle a stack of object. As you can see here, the code is very similar. The only change we've got is the name of the class and the method push, which take for the iStack integer an integer, for iStack string a string, and for iStack object an object. Otherwise, they are very similar. When we want to implement one of these stacks, for example using an array, let's look at the class arrayStackInteger, which implements iStack integer, and the class arrayStackObject, which implement iStackObject. If you look at it, there is not much difference between the two. So there is a lot of code duplication here, and that may lead to error later on. You can see that, for example, I've got an array in integer for an arrayStackInteger, and an array of object for arrayStackObject. And see if I want to do that with another type of data, I will have to write again another class on another interface, and the code will be similar again. So there is a lot of code duplication, and we want to avoid that. What we would like to be able to do is to code once and use many times. So let's look at an example of using these two classes, the arrayStackInteger to start with. So for example, I want to create an arrayStackInteger of size 10, and I'm going to push an integer in the first one, and then in the second one, I try to push a string. And here the compiler is going to help me. It's going to tell me there is an error. So I will have to change that line to be able to run it. Then in the while loop, assuming that I remove my compilation error, in the while loop, what I need to do is to convert the stack pop into an integer. Let's look at the other implementation we had. An arrayStackObject. And again, this time I'm going to use the same code. So I'm going to create an arrayStackObject of size 10. I'm going to push an integer, which is an object, so there is no issue here. I'm going to push a string, which is also an object, so there is no issue over here. Then I'm going to do int product equal 1. Then I'm going to have the while stack empty. I want to pop the element and convert that into an integer. And here the compiler is not going to help me at all. It's fine with me to convert the element from the stack into an integer, even though the one at the top is a string. So when I'm going to execute that program, I will have a class cast exception. It will not be able to convert the string into an int. So that's an issue here. The compiler is not going to help me. It's only at runtime I'm going to find that issues. So that's not very satisfactory. So we've got a lot of issue with duplication of code, but also we are not safeguarded by the compiler. There is an option for that. There is a solution using Java generics. In fact, we used that previously without knowing it. The class ArrayList is a parameterized class. What do we mean by parameterized class? It has a parameter denoted by the base type that can be replaced by any reference type to obtain a class for ArrayList with the specified base type. That started with version 5 of Java. So these classes that have a type parameter are called parameterized class, or generic definition, or simply generics. A class or an interface definition with a type parameter is stored in a file and compiled just like any other classes. Once a parameterized class interface is compiled, it can be used like any other classes. However, the class type plugged in for the type parameter must be specified before it can be used in a program. Doing this is said to instantiate the generic class. An example we've used before is the ArrayList, where I'm going to define the type ArrayList with, in slanted bracket, the type is going to contain, in this case, a string. Then we've got the name of the variable, and then I'm going to construct such an ArrayList using the keyword new, and then ArrayList, and between slanted bracket, the string. This is a parameterized class, and I just instantiated that generic class. A class or an interface that is defined with a parameter for a type is called a generic class or a parameterized class interface. The type parameter is included in angular bracket after the class name in the class definition heading. Any non-keyword identifier can be used for the type parameter, but by convention, the parameter starts with an uppercase letter. The most commonly used type parameter names are E for an element, usually used in Java collection framework, K for a key, N for a number, T for a type, V for a value, and then S, U, V, and so on for the second, third, and fourth type. Something we're going to see towards the end of this video. The type parameter can be used like other type used in the definition of a class. So here we can see that I can define a general interface for a stack called iStack. And then I'm going to have a parameter. The type this kind of stack are going to store. Then I'm going to look at the implementation. So now I'm going to have ArrayStack with a parameter t, which is going to implement the iStack with a parameter t. You can see that I'm going to store an array of t called data. I want you to pay attention to the line number 9. Data equal t array in brackets, new object size. Here I first create an object of array object of size, and then I'm going to cast it into an array of t. Why do I do that? That's something I'm going to explain a bit later on in the lecture. What I'm not allowed to do is to do directly new t size. Then you can see that compared to the other method and classes I've done when I implemented that with integer, object, or string, here I'm going to say that the method push on line 19 has a parameter of type t, and then the name of the parameter. So you can see that here I don't use a predefined type, I just use a parameter called t to define the different type of that class. And I just need to write this interface and this class to be able to implement a stack using an array. Whatever the type of data I want to store in this stack. Note that the constructor heading do not include the t between slanted brackets. So be careful not to add that when you write the constructor of your class. So now let's use this class. So I'm going to create an instance stacks, who's going to be a new array of stack. I define this stack as containing string. On line 44, you can see that I declare the variable stack as an iStack of string. Therefore, this stack is going to contain only string. one thing I can look here, I can add, for example, to push the string 7. However, if you look at line 54, I'm going to have an error. In line 50, I created a stack of integer. And then, on line 54, I try to push a string. The compiler is going to help me here. I've got only one definition for an array stack and one definition for iStack, but the compiler will be able to tell me that there is an error when I do the push. So here, the compiler is going to help us with the class conversion. One thing I can do as well, I will be able to create a generic class that have many number of type parameters. Something which will be very useful when I use a dictionary, for example. In a dictionary, I need a type for the key and perhaps a different type for the value. For example, I want to have a key which is going to be an integer and a value which is going to be a string. I can do that using two parameters. Here, I define an interface iDictionary, where it's going to have the first parameter of type k and the second parameter of type v. And then I can use these two types wherever I need inside the interface. For example, in line 10, the method put is going to take two parameters, one of type k and one of type v, and it's going to return a value v. Similarly for get. So you can see that I've got two types of parameters, and as you can see, I've used the name k because for a dictionary the first parameter is usually a key, and the second v because the second parameter usually is a value. So it's just to be able to help people to understand what are the different parameter types. Sometimes it makes sense to restrict the possible types that can be plugged in for a type parameter. We say that we are going to bound the type of the parameter. For instance, to ensure that only classes that implement the comparable interface are plugged in for T, we define a class as follows. For example, public class, RC class, and then between the slanted bracket, I've got the parameter T, but I've got a constraint on that parameter. This parameter must extend comparable. This is very useful. Extend comparable serves as a bound on the type parameter T. Any attempt to plug in a type for T which does not implement the comparable interface will result in a compiler error message. But what is the advantage to do so? Let's have an example with the class pair. Here, for example, I'm defining a class pair with a parameter T which extends comparable. It's got two attributes of type T, name first and second, and then I've got a method max which is going to return the biggest of the two. Because T extends comparable, I know that any object of type T will have the method compare2. So here in line 7, I can use the method compare2 on first, which is of type T, even though I don't know what will be the type T at that stage. What I know about the type T is it does extend comparable, and therefore it must implement the compare2 method. So that allows me to start to write method on the type, even though I don't know the type, because I know they've got some constraint on this type T. That is very useful. A bound on a type may be a class name rather than an interface name. Then only descendant classes of the bounding class may be plugged in for the type parameter. In that case, the syntax is public class, example class, and between slanted bracket, I've got T extends class 1. A bound expression may contain multiple interfaces and up to one class. If there is more than one type parameter, the syntax is as follows. So I've got public class 2. The first parameter extends the class 1. The second parameter extends the class 2. And implement interface A and implement interface B. So be careful with that syntax. So you can see we can have a very precise bounding type for parameters. And there is more. But that will be beyond the scope of this lecture. So we've got limitation when we look at a type. Within the definition of a parameterized class definition, there are places where another class name will be allowed, but a type parameter is not allowed. In particular, the type parameter cannot be used in simple expression using new to create a new object. For instance, the type parameter cannot be used as a constructor name or like a constructor. So I cannot say that t object equal new t, or I cannot create an array of t with the new t on size 10, something I mentioned earlier. That's why I had to create first an array of object and cast that array of object into an array of t. Otherwise, the compiler is going to create an error. Arrays such as the following are illegal. So if I try to create a pair of string and make an array of it, I will not be able to do that. Although this is a reasonable thing to want to do, it is not allowed given the way that Java implement generic class. If you want to know a bit more about that process, have a read and have a search for type erasure in Java. So finally, let's make sure we know the restriction on generic. To use Java generic effectively, you must consider the following restriction. You cannot instantiate generic type with primitive type. You cannot create instance of type parameter. You cannot declare static field whose type are type parameters. You cannot use cast or instance of with parameterized type. You cannot create arrays of parameterized type. You cannot create catch or throw object of parameterized type. You cannot overload a method where the formal parameter type of each overload erases to the same row type. So that's a bit more complex. That's something when we are going to be able to cast that into an object later on. But that's something you need to learn when you look at erasure of type. Something which is beyond the scope of this lecture. Next week, we're going to investigate a bit more generics, in particular, the Java collection framework, where there is a large use of generics, as well as interface and abstract classes. So that's going to sum up everything we've seen so far about object-oriented programming applied to a set of classes for Java collection framework.